So here we are on Kaggle's Intermediate Machine Learning course, the exercise for cross-validation. All right. So let's click this link to get our stuff up, our text up, which we're not really using that much, but whatever. We've got the setup here. We've gone through this enough. We know what's going on. We've got the housing prices competition for Kaggle use learners. That's going to be our data set. We've got an X and an X test down here. Basically, the only difference from usual is that we're only going to be using numeric columns. We're reading the data, drop now. We got the sales price and all that stuff, and then basically that's what's up. We've got x.head. Let's run this thing. Yeah, take your time. Oh yeah. Don't forget to run this first. Run this, then run this. There we go. We've got a bunch of numbers, no categorical data. And let's go to this part. So far, we've learned how to build pipelines with scikit-learn. For instance, the pipeline below will use a SimpleImputer to replace missing values in the data before using RandomForestRegressor to train a random forest model to make predictions. We're going to set the number of trees in the random forest model with the inEstimator parameter, and we're going to set the random state to ensure reproducibility. There we go. So yeah, just like it said, random forest pipeline, SimpleImputer, we're importing all those. We've got my pipeline equals the pipeline. We're doing the steps. We're going to have the preprocessor first to replace the nands with whatever, or with 0. I don't even know. I think it's with 0, right? And then we'll do the model for the random forest regressor. We're going to have 50 trees on this random state equals 0. All right, so we're good on that. So we've also learned how to use pipelines in cross-validation. True. The code below uses the cross-val score function to obtain the May average across 5 different folds. We'll recall we set the number of folds with a CV parameter. True. All right, so we're bringing in cross-val score here. We've got scores equals the -1 because we're going to be using the negative mean absolute error once we use this cross-val score function. And we're going to do a scores.mean on it and print it out. So let's just do that while we're here after we do this. All right. Take your time. And there we go. We got the May of 18,276. Looks good enough, all right? Not the best, not the worst. So now we're going to write a useful function for step 1. In this exercise, we're going to use cross-validation to select parameters for a machine learning model. We'll begin by writing a function getScore that reports the average over 3 cross-validation folds, not 5. The average May of a machine learning pipeline that uses the data in X and Y to create the folds, SimpleImputer with all parameters left as default to replace missing values, okay. And then RandomForestRegressor with random state 0 to fit random forest models. The inEstimator parameter supplied to getScore is used when setting the number of trees in the random forest model. So basically we're going to be doing this and this, but instead of just having the estimators, we're going to make a function that we can plug in estimators, right? So that being said, first things first, we need to get rid of all this stuff. Drop it down 1, and then we'll come over here, and since we're using this stuff, we might as well take this stuff. So let's just take this my pipeline right here, drop it off right here, and there's the first part, right? Now let's come down here. Let me move this over one. Let's come down here for the second part, and we're going to use the scores part. So let's just grab this here. All right, grab that. Drop that here. All right, so now we got that. So now what we want is we want to return the mean of the scores. So let's come down here and say return scores.mean. All right, so we've got that going on. But the thing is, remember, this is a function, and it's going to take inEstimators as the parameter. So we don't need to have this hard coded in here like this. So let's get rid of the equals 50. And also, we're only using 3, like it says right here. So let's get rid of the 5 and turn it into 3, I say. All right. And then that should be good. Let's run it. See what we get. And it's correct. All right. Let's do the solution. Make sure everything's good. And looks pretty much exactly the same. So there we go. So now we've got step 2. We're gonna test different parameter values, okay? So now we're gonna use the function that we defined in step 1 to evaluate the model performance corresponding to 8 different values for the number of trees in the random forest. We're gonna use 50 all the way up to 400, going up by 50. So we'll store the results in a Python dictionary results, where results at I is the average May returned by get scores at I. Okay. So basically, we're going to be running this on a list of these. All right. So let's start off, because we're making a dictionary. Let's throw a dictionary in here, like thus. Not like thus, like thus, and like thus. There we go. So we've got this. Let's get this year code. We know where it is. Let's get that out of there. So we've got this dictionary right here. So now we're going to have to do a for loop going through this thing. So let's also make a list of numbers. List. Let's say numbers list. Numbers list, and that's going to be a list, I say, with 50, 100, 150, that's not 50, 200, 250, I'll know which one it is without looking one day, 300, 350, and 400, all right? So we've got this list right here. Now let's do a for loop and say for I in numbers list. All right. And so what we're going to do for each one of these, we're going to run this thing on it. So let's get scores right here. Get score, I should say. Let's do get score, and let's put at I. Okay. And then that should be good. Let's also do a print of what we got. So let's say print. Get scores at I. Get score at I. Number list. We need to put it inside of here. So let's say result at I. There we go. Equals get score at I. Okay, I think that's good. All right, so now let's do something like this. Let's say print, and then we'll say let's drop this down more. How about that? Let's say something like this: values equals, and let's do that list comprehension like we've been saying. And let's say in here value for value in result dot values. All right. So we're going to get the values of whatever's in this dictionary that we're creating right here and put it, and then put that in a list. But also we know that it's going to be ints. So let's just wrap this up. Not ints. It's going to be floats. So let's wrap this up and put that int like that. And then we'll print out values like thus. All right. So now I'm going to have to fast forward because this takes like a full minute to do, because it's just going to be a pain. But I'll fast forward and we'll be back in a second. or not. All right, numbers list. What did I do? Equals this. How about that? Now let's run it. Oh my God. Result at I. Result at I. How about that? And now let's run it. All right. Give me a second. How about... Oh, I can't believe it! Give me another minute. Second. Finally. All right. So here we go. We've got this list of the values. We can see we've got... it starts off here at 353, and then it goes up to 395, then it drops down to 288, and then 248, and then 255, and we can see it starts climbing again. So the special number right here, the lowest May, is going to be this one right here. Looking good. So let's look at what they did. And they decided to be smart and make an actual range and multiply I by 50, which, you know what? We could have done that, but that's not what I would have done. I would never have considered doing this off the bat, because I'm not that seasoned yet. So I felt like doing it the hard way. That being said, it is what it is. And let's go. It's basically the same thing. So let's go to the next part. So now we're going to use the next cell to visualize our results from step 2. We'll run the code without changes. All right. So let's look at this before we run it, just because. All right. So we're going to be importing from this matplot library .pyplot, and then we're going to call this PLT. All right. So some plot, I guess. And then we've got this right here. It said it was like a magic command or something when I looked it up in Gemini. Basically, if it starts with a modulo and it's words after that, it's like a magic command in Pandas or whatever, or maybe even this. Or maybe it has something to do with the site. But basically what this is going to do is it's going to put a graph inside of the browser instead of inside a new window, right? That's what this thing right here does. That being said, back up. Markdown in latex. Okay. Anyway, can we get rid of that? Does that matter? Okay, no, it doesn't. All right. So now we got this PLT plot, this plot.plot, and then we're going to have the result of keys, and then the results at keys, and then results.values, And then the keys is going to be on the x-axis, and the values is going to be on the y-axis. Then we're going to show it. So let's watch it happen. There it is. And we can see it starts low, goes up, goes down to this 1 at 200, and then comes back up and blah. All right. So we can see that the lowest one is going to be here at 200, like we saw in our little list right over here. Although this is better looking, right? So here's step 3. We're going to find the best parameter value, okay? So given the results, which value for in estimator seems to be the best for the random forest model? We can use our answer to set the value of in estimator's best, all right? And so we know it's 200, so we'll type in 200. Check the answer. Looks fantastic. Get out of here. And then when we check the solution, we can see they were clever again. Oh, I wish I was that clever, but we'll get clever one day, right? They did the min of the results, comma, key equals results.get. So basically they're just getting the results of these of the dictionary, the results from the dictionary. And it is what it is, all right? So we could have done that, but you know, I didn't think to, but it is what it is. So it's basically the same thing. So in this exercise, we've explored one method for choosing appropriate parameters in a machine learning model. Okay. If we'd like to learn more about hyperparameter optimization, we're encouraged to start with grid search, which is a straightforward method for determining the best combination of parameters for a machine learning model. I hope the lightning doesn't strike and ruin this recording. All right. So let's click this right here, and it just takes us over to a Wikipedia page. Also, I saw this in when I was talking to Gemini about this stuff. So when we actually need to start doing this, we can just get it from Gemini, no big deal. All right. Thankfully, scikit-learn also contains a built-in function, grid search CV, which I also saw in Gemini, that can make our grid search code very efficient. So yeah, this stuff, hyperparameter optimization, takes a long time, and it's very grueling work for the CPU. But you know, that's how we can, you know, optimize, right? Because obviously it's not going to actually be 200. It's going to be somewhere between here and here. And we don't know exactly where, but it doesn't matter. We'll figure it out later. All right. So there's that. So let's keep going. So we're going to continue to learn about gradient boosting, which is a powerful technique that achieves state-of-the-art results on a variety of data sets. All right. So let's go. All right. So now we're on to XGBoost, and we'll see you next time.